Okay, yeah. Let me actually see the slides. That helps. Okay. So yeah, hi, I'm Remer. I'm a postdoc from the Software Analysis and Transformation Group at CWI in Amsterdam, and I'm the self-proclaimed benevolent host of this mini session. For the next hour, we will share our position on what we call first-person real-time collaborative metaprogramming adventures, which is a genre of research. I'll give an introduction, followed by three examples of this type of research. And questions can be posed at the end of each sub-presentation, which will be rather fast. And okay, so we aim to empower game designers and developers with solutions that raise their productivity and improve the quality of games and play. And I posed a question. To what extent can languages, structured notations, patterns, and tools offer them the theoretical foundations, systematic techniques, and practical solutions they need? And in order to answer that question, what is the state of the art in these languages of games and play? Um, I did a so-called systematic mapping study, uh, which systematically maps the whole area. And what came out is an overview of these low gapped languages of games and play, which you can also visit online on this URL, which is on the screen. It's an interactive thing that gives an overview of research areas, publication venues, and summaries of over 100 languages identified in over 1,400 publications. It gives research perspectives, separate ones, that shed light on this topic. And it also looks at general trends and success factors and gives a unifying perspective on automated game design. So I hope that this overview is of special interest to the PLIE community. Let's see, next. So in an analysis of these languages, I found that it is often a very high effort to develop programming languages or languages and tools for games and play. It represents months or even years of development. And what is then necessary is, of course, synergy, reusability in over multiple projects and publications. However, the analysis revealed a graveyard of dead language prototypes. Well, uh, meaning sometimes they were missing, sometimes the code was not really reusable or understandable, or it had no examples, things like that. And unfortunately, that also, of course, prevents things like having additional publications and validating the languages and actually putting it into practice. Of course, there are also success factors that I found and languages that are very well published, such as Able, Casanova, Ludocore, Sharpluders, and others. And those are from very distinct, separate areas of reuse. Oh, my slide thing just malfunctioned. Um, so let's see if it still works. Yes. Okay. So we take the position that by using the enabling technology that is available, applying metaprogramming techniques and language workbenches, you can do better rapid prototyping and create better prototypes more quickly. Um, So of course this has a cost, the time to learn the how to apply these techniques, but there are some compelling benefits, namely to improve the quality of the prototypes, to reduce the code footprint. Uh, Less code is automatically better code because bugs exist in uh, yeah, the more code you have, the more bugs you have. More reusable, more maintainable, and extensible code is what you can get applying these techniques. So there's a delay on my remote. Um, oh, no, sorry. Uh, so what comes up next is three ongoing master projects with distinct goals and applications, and they similarly leverage metaprogramming techniques and apply the language workbench and metaprogramming language Rascal. And as you can see on the little map, we are dots all over Europe, in Amsterdam, Krakow. Uh, oh, look, the yellow dot in France moved to the south. That's nice. Thanks for putting it in the right place. Um, but without further ado, I give the floor to Clément.
You're muted.
We can't hear you.
So yes, so my name's Clement. I am a student at the Master for Software Engineering at the University of Amsterdam. And during my master thesis, I studied puzzle script. And the reason I studied puzzle script is because it's very interesting from a game design perspective, because the code you write for puzzle script very literally describes gameplay mechanics. So in a single line, you can create a gameplay mechanic. So it's very interesting to study puzzle script to as a way of studying how code affects gameplay quality and gameplay mechanics. But we very quickly ran into the issue that PuzzleScript's implementation, which is in JavaScript, is not really suited for research or for gameplay analysis, because its main focus is performance and portability, which comes with a drawback that it's harder to extend and harder to maintain. The code base is quite large. Just for the three main files that implement the basic logic, we're already looking at approximately 6,000 lines of code. And the phases are very tightly coupled, so it tries to do as many things as it can in a single phase to gain in performance, but it also makes the code harder to read and harder to extend. So what we did, what I did is is I came up with a solution of recreating puzzle script with using Rascals, using Rascal by reverse engineering the original implementation, studying its design, understanding what it does, and then we formalized the grammar using Rascal's declarative notation to be able to create a literal definition of what a puzzle script file contains. And then we implement static checking, we implement compiling and gameplay analysis. So the result is we have the phases are decoupled, so that anything we add or anything we modify in a phase does not necessarily cascade and cause errors further down the path. The idea being that if someone is looking for a very specific thing or a very specific kind of feedback, they can easily add that to get that feedback to get live feedback on either code quality or gameplay quality. And the feedback is presented as warnings, errors, or informations attached and shown directly in the IDE. So so the phases, it's the phases of a compiler. So we started by reading the file, then we check the code, we parse the file, then we statically check the code, then we compile the game. There is 5 phases. Yeah, there's 5 phases. There is parsing, checking code, statically checking, which is we're just checking if the code is all correct. We compile the code into a format that is easier to run for the engine. Then we conduct gameplay analysis on that code to understand the state of the gameplay, and then from that we can just then understand whether the gameplay is interesting or not. And then finally the we run the code. So yeah, so So this what you're seeing here is the puzzle script IDE, which it's focused on performance. So the idea is very simple, a very simple system that the player can just use to write games. But the problem with that is the only feedback you get from the IDE in terms of live feedback is the syntax coloring. So you don't really know if something is wrong until you press the run button, which then generates errors that you can see on the right side. But again, it's only a partial report of the state of your game. So this means that you have to hit the run button multiple times in order to get a full report on the errors within your game. So what we do instead, so the result of the project is an IDE written in Rascal that provides live feedback on code quality and gameplay quality, and then presents that feedback in an intuitive way. In this case, it's by attaching error messages, warning messages, information messages directly to the affected line. So if there's a bug, you can see where the bug is and you can see what the bug is. And then once you fix the bug, the message goes away. If you have a duplicate item, if you have a non-existing color, if your sprite is not exactly 5 by 5, the IDE tells you as you write the code. And then once you fix the bug, the message goes away. This also applies for warnings, warnings being unoptimized code. So it's not something that would break. Yes, it's on GitHub, but it's a rather prototype version. So I'm not completely sure how well it works in most cases. But yeah, so warnings, informations, and we see, yeah, so as I'm fixing the bugs, the messages go away. Once we save the file, it compiles and builds, and then it gives us additional feedback on gameplay quality. It's kind of the two aspects of my thesis: is how do we provide code quality analysis and gameplay quality analysis. So yeah, once you're satisfied with uh, sorry. So yeah, so we just finish fixing everything up. So yeah, so the idea is we're already applying concepts like these to programming, so why can't we apply it to game design? Yes, we're defining we're I think more fun is actually one of the ones I not completely sure. We tried defining more difficult, which a simple definition of more difficult if is the level bigger and does it contain more objects, but those are very naive definitions. But more fun, I haven't really put a pin on at the moment. It's probably more fun is very subjective. So yeah, and once you're happy with the state of your game, you can run it, which opens it in a Rascal web app implemented using Salix, the Salix library. And this Rascal web app gives you information on the game as you're running it. So on the left, you can see which victory conditions are met, and you can see which rules are being run, while on the right, you see your game being run as you press the keypads. There, and that's everything. So yeah, we talked a bit about solving things, but our idea was to have live feedback or feedback that is very quickly given. So solvable is harder to account for because some some puzzles can be very expensive to solve. So yeah, I'm my part of the presentation is done. So if you have any questions, I'd be happy to take them. Oh boy.
Maybe you should consider fun in your thesis.
Yes, I can't remember what I did for fun, but we did consider it. But fun might have been something that I briefly touched upon in my thesis.
Hmm.
But I think it was very hard to define what fun is, especially per game.
Yeah.
Defining if a game gets harder is relatively easier than defining if a game gets more fun or keeps being
Oh,
fun.
yeah, definitely.
So yeah,
I think we can you see any questions? More like notes for you. Um,
yeah, I see a lot of interesting notes.
mhm. Okay, we can
Yeah,
continue and you can ask any questions again to come on after.
yeah,
So, hello, I'm Georgia. I will talk about a ludoscope debugger that I am developing for my thesis. This was done in collaboration with Ludomotion. Ludomotion actually created Ludoscope, which is a grammar-based language and tool that can create different generators and also has many other capabilities. My problem, however, was that grammar-based generators are very powerful and useful. However, they provide very minimal quality guarantee as of now. Lever designers of such generators lack debuggers and debugging mechanism, and very minimal research is being done on this matter. So the state of the art right now for debugging generated content is human intervention that's either done by patches or straight up eyeballing and fixing some levels by hand. My objective was very simple. I wanted to help developers make better and more games. We also wanted to provide a form of quality assurance, better means of error logging and debugging, as well as a way to fix errors on runtime. This was the most hard part. So our approach was inspired by Untitled programming, different kinds of solvers like the Z3 SMT solver, some grammar-based approaches as well as Ludoscope, and we looked at Puzzle Script for some ideas as well. We focused on Ludoscope and isolated its core features that we wanted to use to create a more manageable prototype. So our new tool now has a subset of Ludoscope features, but it also has a new syntax and therefore a new DSL that is more readable and easier to learn for beginners. I will show this in the demo. We introduced constraints to guide the generation. Constraints are a core feature of our new tool, and along with them, we provide the designer with the respective handlers. So when you define a constraint, you're given the option to choose what you want to do when the constraint is not met. Again, I will show this. We also added some improved error handling and logging for both parsing and execution errors. And you can see a snapshot of uh, Unexplored on the right, which was created in Ludoscope and is available right now to play. This is my short demo. Um, Here I have initiated the application and have loaded a project to it on the left. You can see the editor on the left that you can scroll and edit. You can also see the new syntax that is a combination of Ludoscope's original with some puzzle script influence. On the right, you can see we have a parsing error. So there is a rule that is not defined in the recipe. We can see that I have mistyped here a rule that is defined above. I'll quickly fix that. And I'll save it. So now the execution runs right away on save. You can see on on the right that the alphabet has been visualized, so the building blocks essentially, as well as the rules in form of small tile maps. Um, so in order to execute it, I need to explain our new feature, the constraints, and how they're defined. The first constraint is defined as a non-exit constraint, meaning that it will only be checked in the end. In this case, what it does, it asserts that there's an exit door on our tile map at the end by checking the count. For the second constraint, we have defined a variable called path, which creates an internal data structure of a graph from point A to point B, representing the path the player will have to cross to traverse the map. In this case, from entrance to exit, from E to X. The path is then constantly checked by the constraint to ensure that no other module will break it. All resolvable constraints like that have a handler for when they need to be resolved. The handler is defined in the backend for this constraint, and what it does is it reverses the transformation for when my path breaks. Um, this will also be shown when I execute it. So going on to execute it. So here we can see the history on the left of how the rules are applied to the tile map and they are transformed. Um, of course, this is randomly generated, so I'll execute it a couple of times and see how it breaks. So now the pillar, as you can see, has been placed in the entrance, in front of the entrance, and the repair module runs in order to fix it. So for now, the handler simply reverses the transformation, but we can also have it rerun the previous transformation or move the object or try a couple of times in order for it to be placed in a more ideal spot. This is still done in Rascal code, so I haven't translated it to this ID basically, but that's the idea behind the handlers of these constraints. This concludes the demo part, and I can now take questions. Thank you. It seems there are no questions, or maybe you're. Um, well, so the whole language is based on Ludoscope's DSL. So the idea of recipes, rules, alphabets, the options part I have added, which was not really shown in this demo, but the constraints are defined. I think they were influenced by ASP and the way ASP kind of creates stuff, but they are syntactically designed by us. The idea is pretty simple, I think, on constraints. Does that answer
So
your question?
it doesn't yet run a constraint solver in the background, right?
Oh well, it it doesn't run a sol. What do you mean, Kramer? It does
That
run the handlers.
there is no integrated um, uh, SMT solver or answer set
Oh
programming
no,
running
no,
yet,
it's simple
right?
logic defined by me, and it's our the scope of our master's project is very small. I didn't have the time to extend. I'm not sure what FOL is. Oh, yeah. Mm, it is first order the way it's been defined and parsed. Yes. Yes. The idea is that the hunters will have some kind of their own keywords and way to write them without actually using Rascal code. Right now, it's pure Rascal the way they run. So it should be more of an external function that runs in maybe similar code to the current DSL uh, in the prototype that we laid the designer to um, write very simple commands. Yes, that is the idea. However, it's not. I'm answering the question about the repair mechanism uh, that it gives the option to rerun the previous rule. This is the idea. It's not implemented, but I would like it. I would like for it to have this option as run another rule or decide to guide the generator into another rule and maybe change the pipeline when a constraint is blocked or is not met. So it's still undecided for that part, but the idea is there, and I would like it to for it to have another rule to run instead of something else.
So, Georgia, could I ask a question? I'm being
Yes.
selfish, of course, but so with these transformative pipelines, you have a transformation that goes forward in time, and it populates this style map step by step with more
Hmm.
details. And if a successive step breaks a previous step, you always have a problem.
Hmm.
And in the composability of different pipeline modules, you sometimes find that they are simply incompatible with each other under
Hmm.
certain conditions, which you can
Hmm.
only find currently by eyeballing and
Hmm.
maybe later by test automating it.
Hmm.
But the mechanism you are creating, does that enable the pipeline to be not just linear but go back and resolve things? Does it help the composability?
Yeah.
And so
So
how could that work?
yeah, so right now I'm defining a resolvable complaint, a constraint of what the designer thinks that is resolvable right now. So that could also throw an error that this is not resolvable. What you are suggesting for me to do, for the generator to do at runtime is not possible. But if it is possible, then that would mean that the generation can be guided wherever and whenever you want, even with positively defined constraints, constraints that never change for that matter, or that are always met. So that's a way to guide generation the way you suggest. So it does affect composability. Is that a
So
yeah?
I think that that's a nice answer. I have one more question. I don't know if this term passed already, but about blame detection. So if a module breaks something,
Oh
what is
yeah.
the current state of the art, and what are you doing exactly?
Yeah. So I purposely left this out of the talk so it could be short, but I know it's there. So what it does is when it an error is thrown on execution, then it says that this module broke this module, and here's how you could fix it, or this constraint is not resolvable. So when this happens, do you want to define something for it to happen and therefore make it resolvable? So right now, when rule, for example, add pillar breaks the rule exit, for example, then you would get an error message saying that when add pillar was executed, it uh, re- broke the add exit rule, and it would be visualized, and also the locations in the code are shown. So you get a very nice debugging message that you can click on and it will throw you in the code and you can delete and fix or define something somewhere else, like a handler for it. Yeah.
Whereas you currently have to actually look
Oh
at
yeah.
the generated
Whereas right
level
now
and
you would
find out
have
the
to look at the generated stuff and see by yourself or scroll down a tile map and check the tiles that are missing and fix it in the code, or like delete it by hand, or claim that this tile map is useless basically and rerun the
so
generation from the start.
So you'd need a sublime mental model to be able to do that.
Yeah,
And we know
like
someone who has that, but not
yes,
everyone, of course. Yeah.
not everyone. You can't really even Ludoscope by itself is very hard to understand from zero to making a great game. It will take you like uh, a lot of hours to master, more than the 100 that suggests for a skill to master. For it is a very hard to learn generator. Yep,
Okay. Um, let's see. We
we can
could
continue
move
with
on.
Yuri. Yeah.
We can move on to Yuri. Okay.
Okay. I'm Yuri Reine from the Master Software Engineering at the University of Amsterdam, and I am proud to present to you the solution, the live interactive code puzzle visualization or Linkopuvi framework. But what is the problem exactly? It is that programming education is far from perfect. So let me explain this. The first problem lies in the languages that are used to teach programming. Often, the subsetting of a general programming language is used, while these are not made for novices. The second problem is that novices, per definition, do not yet possess the necessary skills to effectively interact with the computer. For them, it can be difficult to specify what the computer must do and then interpret and evaluate if it's actually done it. Long feedback loops can hinder the lessons that are being learned, and finally, learning and or teaching programming can be frustrating, while I think it should be fun. This brings us to our objective. We have set out to create an environment for exploration and experimentation. In order to do so, we use a systematic approach and lay out the following sub-objectives. A tailor-made introductory programming language enabling the novice to code. A tool for designing reusable stackable 3D artifacts, and a method for defining, creating, and editing code visualizations. And finally, a live visualization application that allows for free movement and interaction. We approach this ordeal by leveraging Rascal metaprogramming in combination with Unity 3D game engine. This way, we utilize these powerful tools for their strengths and are able to negate their weaknesses by counterbalance. The approach can be dissected into Solvi, the introductory programming language, which is designed using common errors made by novices and introductory language design principles. On top of this, it features support for IO-based code puzzles, which I will talk about more later. Showy is our method for defining code visualizations. We extract the necessary language information, which can then be mapped to custom-built artifacts, with optional directional information for nested structures. Cine is the live visualization application which uses a generated code traversal to retrieve the current code state. Just like Showy, this works for any language tree. Let's make things a bit more concrete by walking through the entire process pipeline together. We begin by creating a code exercise in the Solvi language using in and outputs. Here we see an example where the objective is to determine if the received person is eligible to join the youth club. Three variables are input into the puzzle, namely name, age, and the age limit for the club. The puzzle solver needs to combine these to make sure the isOld variable is correct, and therefore the if statement will be executed. Next up, we need to create our artifacts that could aid in understanding the code puzzle. For this, we offer the Blocky Builder, which lends from 3D printing in the sense that you can create layer by layer of the artifact. Hereafter, you inspect this artifact in 3D space, and once you are satisfied with your design, you type in a beautiful name for your design Blocky and you can save it. Then we combine these artifacts into Showy, a code visualization. The Showy Builder has options to determine how the general scene should look like, and it integrates the Blocky Builder to add or alter artifacts. These can then be mapped to code structures. On the bottom right of the interface, the extracted nodes from a chosen language are displayed. The nodes themselves can be mapped to a created Blocky, an artifact, and its children can be directed using relative direction and offset. Here in the example, the if-else statement is mapped to the created choice Blocky, the then block is mapped to be to the right and a little bit to the top, and the else block is mapped to the left and a little bit to the bottom. Last in the pipeline is Scene, the live visualization application that allows for code to be visualized, execution to be shown, and enables game mechanics based on code analysis. Here we see a simple instance of Scene showing the code from the previous Youth Club example, where the execution is shown using highlighting of blockies. So, let's actually solve the puzzle we have just created. We start the puzzle using the input and expected output displayed on screen, with Bob of age 60 and a club age limit of 50. Therefore, we expect the puzzle solver to output that Bob is too old to join the club. We launch the puzzle using the error enemy prototype. Errors in the code will spawn enemies in the scene at the corresponding location. In the scene, you can interact with the error enemy, which will attempt to fix the player. And they will destroy the scene, symbolizing that errors will break your code. Once the error is fixed in the code, the enemy will no longer be spawned in the scene. However, the output from the code puzzle is still not entirely correct. When this can be seen as in this if statement, on the left side, it doesn't execute the what is inside the if statement. So once the puzzle solver correctly assigns to the isOld variable, stating that the age is larger than the age limit, the output is correct and the puzzle is solved. In the scene, you will now see that the greater than appears and is evaluated, as you can see as it's being highlighted. And then in the if statement, it will also execute what is inside. And with that, I will take any questions that you have. Yes, indeed, Stephen. He says that I've definitely had the feeling that errors have fixed me while programming. Indeed.
They have changed me.
Have you run user tests? Well, with myself as only user, so not really. It's it's been a lot of work, and it's only recently that
Again.
it actually is working as a whole.
Yeah.
Yeah, of course.
Also, these theses are supposed to have a very small scope, so um, around 3 months actually. So yours already doing too much work.
I sorry, I'm just a
Hello.
little confused, and I may not be I may not be the only one, so stop. Maybe this is obvious to everybody else, but I, there seems to be a metaphor that you're trying to draw between game gameplay, I think, and programming. Um, and I'm not quite sure what that metaphor is. Like I gather that there's some sense in which the code itself is being visualized in a 3D world, and I'm a little bit lost about like what the kind of correspondence between like I don't quite know what a code puzzle is. Maybe that would be a good place to start.
Yes, indeed. So a code puzzle is the combination of the code exercise and the visualization. And this
And by the visualization, that's something that the student creates or that the your engine creates.
it it could be created by the student, but the idea is that the puzzle creator in this instance is the educator, and they create the code exercise that is corresponded with that corresponds with a learning goal, and then have some sort of visualization that can express some analogy about the code that can help understand that can help the student understand what the underlying code structures are doing.
Okay, and those are generated somehow from the structure of the problem, or are they like which parts are the is the educator kind of hand authoring versus which parts are automatically is there some automatic generation of code puzzles, or am I totally on the wrong track?
It's the visualization is created by the educator. So they determine, okay, I have an if statement and this needs to look in this way. And the part that is contained in an if statement, so the code block that is contained, needs to be spawned on the left side of my artifact. And in this manner, you can uh, it is sort of generated in the sense that you never know beforehand exactly how the code should look like, but you can state how every part of code should look like, and you can determine sort of control flow you can see as pathways, and individual nodes you can see as an artifact.
And that's something that the educator gets to decide what the
Yes,
visual correspondence is to the
yes,
code. Okay, okay, cool. Yeah, okay, cool. I think I just had some very basic clarification questions. I appreciate that. It seems like a cool project. My idea for what to recommend you look into is maybe not as relevant given that clarification, but I was going to suggest that you take a look at the bots educational programming language or educational programming game um, out of my colleague Tiffany Barnes's lab, in which the it's kind of Zachtronics like in the sense that like you've got a palette on the side of the screen where you connect a bunch of code together to make a robot navigate a 3D grid virtual space to accomplish particular puzzle tasks.
yes, exactly. So that's very much related to uh, all of the related work that I've uh, looked at, in the sense that the visualization is only connected to the execution of code. So the effect that executing the code does is visualized. But this framework offers a step towards the student, in the sense that the state of the code is also included in the visualization.
Right, right, yeah. So it's a little bit. It's like kind of taking that. There was an idea. There, one of the examples in Kate's talk had a like a version, an extended version of Scratch, where it was like showing visually highlighting the line of code as it was executing or something, which I think is a simpler version of a similar kind of idea. Um, it might be worth maybe framing this in the language of notional machines. I think part of kind of what's cool about this is that you're kind of giving people a way of like realizing in a 3D space like what a what a particular notional machine might look like for a student, which is cool.
Yep, I think it's cool. Any other
Uh,
questions? Because I think we could
Move on to
wrap it
conclusions.
up.
Well, maybe I can ask a question. So there was one question on the chat about validation, right? That you make something, it's intended for education, then it makes a whole lot of sense to start putting it in the hands of students to see, well, do they form better mental models, things like that. But you are actually creating a framework here that is enabling a type of research. So what does your validation consist of?
My validation consists of creating uh, a realistic code puzzle progression. So working towards an actual assignment from a university in an introductory programming language course. So dissecting that into the individual pieces that are needed to uh, yeah, solve that assignment, and then creating a progression using code puzzles with accompanying interactive visualizations, and then creating two distinct prototypes with game mechanics based on code analysis. So we have this shooter based type where error enemies are spawned in the scene where errors occur in the code, and we have a platformer based game mechanic where branches in the code are uh, that are not executed will be falling once you interact with them in the scene, and uh, collectibles are spawned at the end of every branch to incentivize the player to actually walk across every branch of the code and see that some branches are actually not executed using the control flow. Uh, yeah, so
So,
those
so
things.
if I understand it, you create these prototypes using your framework and showing that you can create prototypes is a validation of your framework itself. And then because your project is rather short, you could say, okay, people, here's the start prototype project. You can continue and develop it and improve it.
Yes, because previous similar types of frameworks have been presented, and the only way that this can properly be validated using students is introducing this as uh, part of the curriculum and teaching the students and having it be part of action research that stretches preferably over a year, and that's not within the scope of this thesis.
Right. So your idea is that actually, as it is being used, it's being adjusted to what it's needed for.
Yes.
Okay. So of course you can't fully validate it then because you're not doing everything. But I suppose this is as close as you can get in the scope of the project. Yeah. Okay.
Yeah,
Thanks.
and we went for very high customizability. It's very open in where you can go, but I think it's time
Uh,
to do some
yes.
conclusions.
Yeah, move
We,
on.
we we give the word back to me.
Yes,
Yes.
I will
Okay.
put it.
Okay. So we've just seen three different master projects on which are supposed to clarify our position that by using metaprogramming techniques and language workbenches, you can rapidly prototype in a 3-month project. You can create code of nice quality, a prototype that you can actually build your research on. And does, oh, does my remote work? Yes. So three ways of serving the plie community with metaprogramming that we see are, uh, so we could boast features of metaprogramming languages and say, oh, look at our beautiful matching and our built-in parsing, syntax definitions, and then dazzle you with manuals. And then you go like, okay, but how am I supposed to use that, right? It sounds all very high tech and stuff. But so that's just one thing, a tech manual. And then demonstrating applications of it to this interactive entertainment domain is a better way, I think, to make this point. And actually, I think the three presentations and the code that goes with it are demonstrations like that. But next. One can also consider that language design is a research dimension that you can separate out from the goal dimension of, let's say, creating educative code puzzles, that you study the languages to create those code puzzles in order to create actually the opportunity to work on high quality language prototypes and to publish more than one paper on your language, because you need to, because it's such a big investment. Studying existing languages is, of course, also something, well, we can learn better what they mean and validate them. And we have two examples here that Ludoscope and PuzzleScript are existing languages that we want to understand them better, and why do they work so well, and catch up with the theory and the practice of Ludoscope, right? It's amazing. It works well, and I would like to understand better why it works well, and how to make it more testable and things like that. So um, then ending in an invitation, let's collaborate on what? Constructing a roadmap on for plie, for languages of games and play. What are topics that should be worked on, and how how do you approach this? Well, we believe with metaprogramming adventures, and well, I would be happy to discuss how to go about that with anyone who's interested, and yeah, discuss it. And that wraps up our presentation. So I'm open to questions on our position now.
Thank you, Chris.
Thank you very much.
I think we're within the time, so
Yeah.
did our best to organize it.
Yes, absolutely.
And squeeze all the presentations in the time that we got.
Yeah.
And I could add that our position paper that we have is perhaps also itself still a work in progress, and it needs clarification. But with the completion of the master project, I think that we will have more code to share and ways to clarify our position further in order to serve the plie community, because that was what the paper was intended for. Okay, thank you.
Thank you, Rimmer.
I have a question, if no one else has a question, but I want to defer to others because I don't know. I don't know that my question is important.
Go ahead.
Yeah, please.
Okay, so I'm dating myself now. I'm old enough that I grew up at a time when if you were doing AI programming, you were doing it in Lisp if you were in the United States and Prolog if you were in Europe. Although there were a few heretics who used languages on the wrong continents. But in those days, this kind of an argument wouldn't even have been needed to be made, because that's what everybody did. Everybody was doing embedded languages in either some version of Lisp or something Prolog like. Um, is this still controversial? I don't understand why everyone isn't just always doing this. I guess that's what it comes down to.
Yes.
Well, what I would think is that there are now so many technologies available. Actually, the languages we show are all external DSLs, right? They don't actually use the semantics of the host language, but they have their own syntax and their own compilers running with it, which has advantages and disadvantages, of course. But yeah, I believe that finding the right tool for the job is very important. And in a research landscape where there are so many technologies and so many different ways in which you could go about solving a problem, I believe making the point that please use the available technology and the enabling technology that is created, say in the software language engineering community, please apply it, because there were some papers of people who were suggesting to do this, but they were showing toy examples, and not all prototypes, or let's say many prototypes, many language prototypes, don't do that, and yeah, they remain sort of in their a bubble of their technological space. And by applying these language workbenches, I think you bring it out. So maybe that makes it more controversial. I don't know.
I mean, it